And today we're going to talk more about, we're going to write some image transformations throughout the class. And really, we're going to write like one image transformation throughout the class. And the image transformation we're going to write is going to be this one here, where we're going to do a checker pattern over an image. We want to be able to draw that checker pattern. And when you see a complex problem like this, we want to break it back into smaller problems, which leads us back to this process, right? We really want to talk about the process of doing an image transformation. And here's a good way. And we're going to just kind of go through this process and do this one thing. And we want to start small, right? When you're doing these kinds of things, you want to start small. Because, it's a big problem, because this is what we're trying to do. We have this image. In fact, we have this really big image. The cat image that I want to use is actually 600 pixels by 800 pixels, right? So this is going to be cat.jpg, but really it's any image. It should work for any image, not just cat.jpg. So we want to start small, but what we're trying to accomplish is we have an image, and inside this image, we have some region. And inside that region, so maybe this corner up here, probably didn't draw it very well, but there, that looks better. So maybe, not really, actually. Let's say we want to start here at 100 by 100. Maybe that's what that is. And we have a length of 200 on each side. So it's a square. And inside of there, we have a checker pattern where we have red components and green components. And think about that for a second. That's actually a fairly hard problem, right? I don't really know how to do that right now. And so it's a good idea to start small. Let's think about, how can I do something smaller? And we can start maybe with a small image. Maybe I have a small image, and this is a very small image. I just drew it big, but let's do something that's 4 pixels by 4 pixels, right? A 4 by 4 image. And let's just say all these pixels initially are red. Times like this, I wish I had Photoshop and I can just click in there and turn the whole thing red. And then let's say in the middle of all that redness, in the center of this thing, I want to draw a region, and I'm kind of, oops, let me make that fatter. I want to draw a region in here. And I want this region inside of here to be white. But notice the sizes right here, right? This is a 4 by 4. This is a small image, but it's still a bit complicated, but we can figure out these steps a lot faster than we can figure out, well, I don't have any clue how to do that one. So let's figure this stuff out. Let's take a look at how to do this. And we're going to start with this, we'll call this step 1.1, right? Let's create a red image. So first up, we're just going to create a red image. And let me make sure I save this into something I can find later. We'll call it checker.py. And image library, right? We know we're going to be using image stuff. I have it in my folder already. This needs to be in the same folder as the image library, which I have in there. So I have my image library in here. Here's my checker.py file. There's my cat image, all in the same folder. And let's go back to this real fast. And there's some things I want to think about when I'm doing this. Because the problem told us to think about a method with an image, a start row, a start column, and some kind of length. And if we were to look at this image here, you know, what's the start row? Here's the start row. More specifically, let me say this 100 is the start row. And this 100 here is the start column. And this 200 here is the length. So that's how we would normally use that method right there, is we'd have to figure out all those things: start row, start column, the length of the box. This particular box would have 200. Let me just steal the method here. So we need to define all that, to have all that in there. And so we're going to have this, take an image, start row, have a start column, and a length. And the first thing, again, start very basic. We just want to return the image it's passed in. Just because we want to keep this very, very simple. Incremental development, keep it very, very simple. Actually can't see that, can I? There we go. But let's go back to what we're trying to do here. I want to do this version first, because it should still work. In this version, I need a red image. And we can create a red image using this create image method from the library, which takes a height, a width, and a color. So create image, a 4x4, and I want it to be red, so I have to pass a tuple with a red color in it. Of course, I can't see the image, so let's actually write this to file using the image stir to file, which is also, this is the one we used yesterday. Image stir to file, which takes an image and a file name. So I'm going to pass the image, and then I just have to give it a file name. We'll just call it output.txt. And think about what this is going to look like. Before we actually run it, let's actually think about what this should look like. We're going to have this 4x4, which is really 4 columns and 4 rows. And every single one of these is going to be red. And red is this for the tuple, which is the RGB, full intensity for the red component of the tuple. We have a total of 16 pixels. So I expect to see, obviously I didn't fill them all out, but we expect it to look like that. This is going to print out all the tuples. Create image not defined. Let me make sure I have everything in there correctly. I probably didn't spell it correctly. Yeah, it's create img, not image. And now I have this output text file in here, which I'm just going to open up inside of Notepad++. And we can see 255,000, 4 columns, 4 rows. So the whole thing is in there. And so this confirms that the file shows what we expect, right? We expect it to look like that, all reds, and that's what it looks like. So we've confirmed it. And so this is one of the benefits, by the way, of doing small files, is that we can print out the contents and we can validate the contents just by looking at the results. So let's move on to the next step. That's like the very first thing, right? We created a file that we can play around with and test. And now I want to make the center part of this image in here. So I want to make this part of the image in here. I want these components to all be white. So I have red in all the surrounding pixels. And I have white in the center. I want to be able to make that image. That's kind of a good practice before we get to the bigger problem. So what should the arguments look like for this, right? We have to figure out how to call this method. We have to call a checker pattern, start row, start column, and some length. And so let's actually define some variables down here. We need to know what the start row is going to be. We need to know what the start column is going to be. And we need to know what the length is going to be to recreate this image. And remember, row 0, 1, 2, 3. And I'm going to draw this on the bottom. The column 0, 1, 2, 3 mean the same thing. I suppose I could draw it. It's actually bothering me that it's on the bottom. 0, 1, 2, 3. So we have the row, we have columns. We have to think about where we're going to start. And so what value should we use for these three arguments? Anybody know what the start row should be? Start row, yep, should be 1. Start column was also going to be 1. And then what's my length? Now my length is 2, right? I'm only doing 2 pixels. So now, go back to my code. Let's actually call this method. I don't need to return the image, even though it does. I don't need to return it because it just modifies the original image, but I could return it if I wanted to. So there we go. Start row 1, start column 1, length 2. Now, if we run this, it's going to go back and change my file, which actually didn't change at all. These components right here didn't change, these 4 in the middle, because our method just doesn't do anything right now, does it? So we have to implement this function to make this work. And so we want to update the function. And we know we're dealing with nested, or a two-dimensional array, or two-dimensional list, sorry, too much Java, two-dimensional list. And we need to use nested for loops to go through each and every row and then each and every column. So for R or row, whatever you want to use, and we're going to use the height of the image. And then for every column in range, use the width of the image. And for now, I'm just going to throw in some numbers. I'm just going to throw in a pixel. Let's just do all white. Obviously, that's not what the answer is going to be, but at least it gives us a little bit closer to our goal. So if we run this, and instead of reopen, this thing automatically just refreshes my file, and we can see everything went from red to white. So it worked, right? We changed each and every pixel. However, that's not our goal. It's just a step in the process. If we look at this and we think about, okay, what do we want to do? Well, we want to start here, and we want to start here. And we want to turn that pixel into white. In fact, let me just actually get rid of all that. And we want to turn this pixel into white. And then we need a loop. And initially, by the way, we know that this is start row. And we know this other one over here is the start column. But we have to only go 2 things. We want to we want to do this next one. And at some point, we need to end this. So we need to define some end column and some end row. And we want it to stop. But we want to at least do that second one. So let's actually think about those variables. Let's create something similar. So end row. And how do we figure out how many pixels we want to go? Well, we want to go the length. And you're going to notice something in a minute that you may have already figured out. If I add the length, am I really going to 2? Or am I going to 3, right? It's actually not going to go to, it's not going to stop at 2. The end column is really going to stop at 3. 1 plus 2 is 3. The end row is also going to go to 3. But remember, the way a range works is if we use these for a range, is it excludes the 3. So if I use these as the range, so instead of using height and width, if I do a range at start row, end row, and I do a range of start column, end column, it's going to start at 1, and then it's going to do 1, 2, and then at 3, it'll stop. It won't change 3. And this will happen for both of these. Let's run it and see what happens to our file. So notice now everything around it is red. And yet the 4 in the middle are white. Sorry, I'm trying to zoom in. I'm not sure how well you all can see that. Control num. Oh, it's this one right here. Okay, so the ones in the center are now white, and the ones around the edge are red. So we've confirmed that that's what the image is doing. Let's actually save this image, though. Let's save this image using the save image function inside of the library. The save image function here. We pass it the image, and then we give it a file name. And remember, we have to give it an image file name, so JPEG. And now if I run this, you'll notice I get an image right here. It's a little small because it's only 4 pixels by 4 pixels. But you can see a white center and it's red on the outside.